Welcome to all of you. In this lecture, we are going to discuss about the DAA instruction of 8051 microcontroller. DAA stands for Decimal Adjust Accumulator. So this instruction is applicable only on register A, that is the accumulator of 8051 microcontroller, and it has to be used for BCD arithmetic purpose. It is always used after the add instruction or add with carry instruction. First, let us go through the binary coded decimal representation. The decimal numbers from the range 0 to 9 can be represented by using the 4-bit binary representation, that is 0000 to 1001. So these numbers are called the binary coded decimal values. Let us get into the working of the DAA instruction. So as we know, it is going to be applicable after the addition instruction only. So after addition, if the auxiliary carry flag is equal to 1, then 6 is added to the lower nibble of the value. Or if carry flag is equal to 1, then 6 is added to the higher nibble. Another criteria, if higher or the lower nibble, if the value is greater than 9, then to the respective nibble the 6 will be added to that one. So if any of these criteria are occurring after addition, then 6 will be added to the respective nibble. Now let us get into the example for this one. So let us have an example here. So let us consider a number. So it is 29H we are going to consider, and then 18H we are going to consider, and then if we make an addition of these two numbers, we are going to get 41 in hexadecimal, right? So always you try to remember, we are trying to perform BCD addition, but the values we cannot provide that in the BCD. We have to provide the values in the hexadecimal only in 8051 microcontroller. Now if we convert this 29 to BCD representation, so this is going to be 0010, then 1001 is its value, 18, so it is going to have the value 0001, 1000 is what the value we are going to have. Now add these two values. So here it is 1, then 0, then it is 0, then 1 1, it is 0, carry is generated here, then 1 1, it is 0, carry generated, then 1 1 0, carry generated, then 1, and then 0 we are going to have. So here we can observe that, so a carry has been generated from this position 3 to this position 4. It indicates auxiliary carry flag is equal to 1 in this case, right? Now as per the procedure what we had gone through, so we can identify that. So if auxiliary carry flag is equal to 1, then add 6 to the lower nibble, right? And in this case auxiliary carry flag is equal to 1, so we have to add 6 to this lower nibble. From the higher nibble, so carry has not generated, therefore we are not touching that higher nibble. So 6 has to be added so that we can get the result in the BCD format. So 6 is added, that is here it is 0110. Add this one, so it is 1, then 1 1, and here it is 0, then remaining we have to return as it is, and this value is equal to 47, right? So in decimal, if we add 29 plus 18, so we are going to get that as 47. So this is in case of decimal I am talking about. But what actually happens inside is what hexadecimal operation. So we need to convert this hexadecimal value result what we have got to the decimal. At that instant we are going to make use of DAA instruction, right? So that means once we got this result out of add instruction, after this instruction the result will be stored for us in the accumulator, right? So result will be available for us in the accumulator. After we got this result, we use the instruction DAA. Now the value within the accumulator is going to verify the criteria of auxiliary carry flag, or if these nibble values of the result is greater than 9 or not. Then after, if whichever the criteria applicable, based on that 6 will be added to that one. So this is what the decimal required answer. So this is what decimal answer what we have got, that is the BCD result. Thanks for joining.